Hi everyone. So this is for year 9 for Thursday the 7th of January. Basically, I'm going to go through what we're going to do in today's lesson. It's obviously going to still be on Hegarty, but I want you to watch this video first. So the first thing I want to say is the tasks over the last couple of days, they may still appear to you on your task list. That's only going to be the case if you either haven't done them or if you did not get a high enough score. So if you look at the screen, it's basically, I'm calling it home learning, but it isn't really home learning. It just says some of you have more tasks set than others. Some of these tasks you won't be doing in today's lesson. The tasks we're going to do in today's lesson are these 4 tasks here, and I'll get onto that in just a moment. So if you see any of the tasks that you may recognize because you've had a go at them over the last couple of days, these are tasks 536, 537, and 538. So that the problem solving with the circumference, and task 540, 541, 542, and 543, the problem solving with the area. Now, basically, if you have any of those, then it's because you did not get a high enough score, and I want you to try again. So you can watch the video I made yesterday because it should help you out on the majority of these tasks. There's also a Hegarty video for each one, and if you actually bother to engage with the Hegarty videos and watch what he does explain how to answer the questions. And finally, and I've already had a few people asking me for help, and I try really hard to email them back very quickly and answer their questions. You can always do a screen cap, which is the Windows Shift and S, or you can print screen and put that into Paint and crop it from there. There's lots of methods to take a screen capture. You put that into an email to me and tell me precisely where it is that you get stuck. I can help you out. Okay? So I want everyone to try to get at least an amber score on these tasks, and I will help you as much as I possibly can to help you achieve that. Okay, so that's the first thing to say, but you won't be doing any of those tasks today, so please make sure that you click on the right tasks today. Okay, talking about today, we're going to be doing arc length and sector area, and the tasks you need to be doing today, don't click on them yet, by the way, because I am actually going to explain what to do. Okay, I'm going to explain what to do, so don't click just yet. But the tasks for today, so you might make a little note of this, please only do during this lesson 544, 545, 546, and 547, which are on arc length and sector area. Okay. Oh, I've just realized I need to plug something into my computer and I don't have the time to edit the video, so one moment. It's a thing to write on so that I can write on the PowerPoint. I really should have, obviously should have done this before I started recording. Hope everyone's all right. As I say, any problems whatsoever, you just send an email or ask on Teams. Right, this should be working. Right, so basically we've got a few different questions here. The title for today is arc length and sector area. So this here would be the title, arc length and sector area. And basically, a bit of an arc. So arc is a bit of the circumference, basically. And it's going to depend on the angle that you've got. So if you've got a small angle, then you'll have a small bit of arc. If you've got a 90-degree angle, you'll literally have quarter of the circumference. And if you actually have the full 360 degrees, and the arc is the whole circumference, right? So this red part here is called the arc. Okay, and so my first example that I'm going to go through, I've got 3 questions here. Find the arc length, so find how long this red line is. Find the total perimeter, so it's going to be the arc plus this length, because it is, at the end of the day, just a 2D shape with 2 straight sides and 1 curved bit side. And the total perimeter is, you got to add it all up, and then find the sector area. So basically there are 2 key formulas, and I'm going to write them both down now. So the formula 1, arc length, well, you want to think of it as it's a fraction of the total circumference. For example, if this is a 90-degree angle, what fraction of the whole circumference is this? Okay, so it's a quarter of the full circumference, right? So for us here, this would be a quarter of, the full circumference would be pi d. So pi d, which would be a quarter of pi times, I guess 17 is the radius, so double that and it's 34. And then this is what you can type into your calculator, okay? If we have a more complicated situation though, for example here, where the angle is not a right angle, for example, could be much more complicated, like here 117, the fraction we actually use is, so we use the Greek letter theta for a missing angle, and it's out of 360. So the fraction we're going to be using is the angle theta. So the angle, it's written like a 0 with a line through it, basically. So the angle is theta. That's another letter from the Greek alphabet, and it's used in maths to stand for a missing angle. So it's theta out of 360 multiplied by pi d. And if you notice, that actually works even in this situation, because the theta that we'll use in this question, so this theta here would be 90. And 90 out of 360, well, 90 out of 360 is, of course, simplifies to a quarter, right? So 90 out of 360 is a quarter, which is what we had up here, right? Which is what we had here. And of course, what if it was the full thing? What if theta was 360? Well, then it would be 360 out of 360, which would just be one whole, and then you just recover the original circumference formula, pi d. Okay, so this is your arc length formula. So I'll put that in a box. Okay, so I might write it again here. Or maybe I'll insert a new slide where we can just keep all the formulas together and write them out nicely. So let's just quickly draw a little picture. So if this isn't a sector with radius r, an angle theta, and we're going to say that d is 2r, which is the diameter. So that's a sector with an angle there, and basically you've got one of the formulas is arc length equals theta out of 360 multiplied by pi d, right? Because it's a proportion, it's a fraction of the circumference, right? Just remember the very important formula, c equals pi d. So that's arc length. So for us, if we can actually answer this question now, find the arc length. So we're going to do 90 out of 360 times pi times the diameter, which would be 34, remember. So you do need to make sure that you are either using the diameter or the radius correctly, depending on the formula, right? So this is 17 over 2 pi. And if it asked it for 1 decimal place, for example, I can press the SD button, and that's 26.7. Right, let's change color because we're using this color too much here. It's getting a bit complicated. Right, find the perimeter. So what do you need to add to this 17 over 2 pi? Or what do you need to add to this 26.7? Because the total perimeter is this bit of arc length plus a 17 that goes here, and plus this 17. So all you need to do is add basically the 2 17s on. So add 2 17s. So that would be 60.7. And if it asked it in terms of pi, then you'd literally be doing 17 over 2 pi and then write plus 34. So this is getting a bit congested actually. I should have thought about this a bit better. Let's copy and paste this. And can I clear this a bit? Let's get rid of this so we got a bit more room. I will get better at making videos. I just still haven't even really made that many, and haven't made any for such a long time. So just for the record, this is going to be on the low end of the in terms of quality, but I'm obviously going to try to improve. So plus it's not when I'm trying to make this during like a 50-minute free, you kind of have to sacrifice quality a bit. Find the perimeter. So we're going to have 17 over 2 pi, which was the arc length, plus 34. And we would leave the answer like that if it wanted it in exact form. Okay. Obviously, if it wanted it to, you know, rounded, you press the SD button and just write it. Okay. Now let's talk about sector area. Because once I've actually kind of talked about these formulas, we can just apply them basically. So the sector area. So this time I'm actually wanting to work out the area of this. So basically it works the same way. So the second formula, so I've got the first one here, second formula is sector area is again a fraction of, or you know, it's a proportion of, it's some percentage of, it's not the full amount of the area, it's a fraction of it. And that fraction is given by the same fraction as before, theta out of 360 times pi r squared this time. Right? The way I want you to think of this is it's a fraction of the total area. Right? And I'll put the total area in speech marks because it's like, what would it have been if it had been a full circle? What would the area have been? Well, it would have been pi times 17 squared. And there you go, there's your answer. However, this is a quarter of that, isn't it? Or rather, we could maybe better at this point to start thinking it was 90 out of 360 of that. So it's a fraction of the total area if it had been a full circle. This works exactly the same way as the arc length. It's the same idea. So so for us, this is going to be 90 out of 360. So this is for this question up there. Multiplied by pi, multiplied by 17 squared. And so it's just whatever that is. So 90 out of 360. I'm using the formula directly. I know, of course, that that's just a quarter. I also know I could have worked out the full area and then just written divide by 4, right? But I'm using the formula and substituting into it as written. Times pi times 17 squared. So this is 289 over 4 pi. And if we're bothered about units, of course, for the arc length and perimeter, those would have been centimeters or meters or whatever it is. And for this would be centimeters squared, right? So this is being measured in centimeters squared. Okay. And again, if it asks to round it at this point, you now press the SD button and you do the correct rounding. So I'm just going to write down the sector area formula. So sector area is, well, it's a fraction, which is the angle that you're given out of 360 times by, this time, the area, which is pi r squared. Which so it's basically, it's very similar to this, except instead of the circumference formula, it's the area formula. And if you want to, we can also write down the formula for the perimeter as well. Just while we're here, we might as well. It's this theta out of 360 times pi d. But then what have you got to add to it? You've got to add a radius and add another radius. So we could write that as 2 radiuses. Now this formula, by the way, I think I will bother to point this out to you if you haven't already noticed it, can be written differently, right? Watch what you can do. So I can write theta out of 360 pi d plus 2r is just, I'm just adding a diameter on, aren't I, right? Because the diameter is 2r. And you could even go a step further and factor out the diameter here. So it's a common factor of both of these terms. However, that's not really a particularly useful way of thinking about this formula. Okay, so anyway, you've got these formulas now, and I hope I've given a relatively reasonable explanation. Of course, if you're stuck at any further, well, I am going to go through a few more examples. But at this point, you could just get started on the Hegarty tasks, which again, I'll just say to you are task 544, 545, 546, and 547. There is something to say about task 547 if you do want to get started. Will you do question 1 and 2 and make sure you get them both correct, and then just press skip on question 3, 4, and 5, okay? I just want to see a 40% score for this task. The reason is it because the remaining 3 questions use trigonometry, and don't even use trigonometry that you're going to be taught to begin with. It uses the area of a triangle formula that involves the sine function, which is not what you are doing at the moment. And I just want you to skip those questions, okay? Right. For those of you that want to watch a few more examples, here we go. So find the arc length. I'm going to do 117 over 360 and multiply that by pi times 19 doubled is 38, because remember, I want to use pi d. So whatever that is, so we have to use the calculator. So 117 out of 360 times by pi times by 38. So I'd just be very careful. It's going to be very easy to make silly mistakes, whether have you forgotten to double the radius to use the diameter? That's the sort of mistake that you can make, so you do need to be careful. So this is 247 over 20 pi, which to 1 decimal place is 38.8 to 1 decimal place. Right, so that's that one. The perimeter is just going to be the answer we just had, so 247 over 20 pi, but then I've got to add 19 and add 19, which is me actually adding 38. So this would just be 38 more than this previous answer, so 76.8. Right, and then lastly, this one here is 100, the sector area. Again, it's a fraction of the full area of the circle, 117 out of 360 times by pi times 19 squared, right? This part here is the pi r squared, which is the area of the original circle. So whatever this is. So, okay, 4,693 over 40 pi. And of course, you can press the SD button and write an answer. Okay, next question. Arc length. So just be careful if you're given this angle here. Remember, you actually want the angle that's inside the sector, right? So you want this angle here. Right, this is the theta that we need to use. So I'm going to do 360 take away 52 because I'm feeling lazy. I can use a calculator. It's 308. So there you go, 308. And then it's the same idea as before, right? It's 308 out of 360 times by pi times by this time 32, because the diameter for us is 32 and the radius for us is 16. So you've got to be very careful what you're using. And at this stage, I'm not going to type the answers into the calculator. Like, you can definitely do that, and I don't want the video to be too long. The perimeter will just be this plus 32, because I'm going to be adding a 16 and adding a 16. And then the sector area will be 308 out of 360 times pi times by 16 squared. Okay. So basically the only difference between this and normal circles is it's a fraction of the circle. Okay, that's what a sector is. And it's any part of the circle is going to be a fraction of it, but the idea is a sector is quite a simple fraction of it. It's given by the angle of the sector out of 360. Right, and then lastly, this is in task 547 and it's for question 1 and question 2 only. It's how do you find the area of a segment? Now, I'm not going to talk to you about it where theta isn't 90. The reason for that is, as I say, it is involving more complicated maths that you are not being taught yet. However, we can do it in this situation when it's a right angle, because what we're going to do is we're just going to say the segment is just the full sector, right? The full thing, like it's the green bit plus the triangle. That's the sector. But if I take away this triangle, are we left with the segment? So for the sector, I do 90 out of 360 times pi times 17 squared. Remember, this is an area, so it's pi r squared that I'd be using. And then I will take away the area of this triangle, which is a half times base times height. And if I type that into the calculator, I'll get the area of this. So 90 out of 360 times pi times 17 squared. And then if I take away a half of 17 times 17, that's me taking away the triangle. Okay, so if it wanted it in terms of pi and it wanted an exact answer, you'd have to do this bit separately to this bit because the calculator is just going to give you the decimal. But if it just wants it written to one decimal place here, I'd write 82.5. And I guess for us it's meters squared, isn't it? Right. I hope that's been helpful. Definitely get started with the tasks if you haven't already. We will have an opportunity to practice this further, of course. Any questions, let me know on Teams or send me an email. If you notice any mistakes, by the way, in any of my videos, please do get in touch about those as well, so that I can make some corrections as well. Hopefully I don't make any silly mistakes, because I am trying to do these quite quickly, and so there will be mistakes that appear. So if you notice one, please will you let me know. Okay, thank you. See you later. Bye-bye.